Thank you. Well, my name is Martin Peters. I'm from the team of com2m, and we provide software solutions for machine-to-machine communication and Industry 4.0. We're a spin-off from the University of Applied Science and Arts in Dortmund, Germany, and we founded our company at the end of 2013. What we do is we provide not only individual solutions for the market of M2M, but we also provide a software platform as a service that can be used to very efficiently build machine-to-machine communication applications, for example, monitoring applications or remote maintenance applications. We also cooperate with a partner who builds hardware. So the first question that arises when we talk to customers usually, how do I connect my machine with your software? That is why we are operating together with a partner who builds hardware. And that allows us to very easily integrate different machines to our software solution without any initial investment. So that's something that makes our solution very special. We also provide the complete software stack. So if you've once connected your device to our platform, you are not only able to monitor your devices using a web interface, you're also able to use different mobile applications, and you can basically get informed, for example, if there's something wrong with your machines directly using push notification to your iPhone, for example. If you've got an error message, for example, you can also directly use the iPhone app to access your machine online. So you're not able to monitor. You're also able to actively control your machine and, for example, to try to fix an error or problem or to plan your the trip to fix the machine. So we provide different solutions in software to improve your processes and, well, yes, to monitor and remote maintenance your applications. Thank you.
Thanks. That was a quick one.
Yeah.
So,
Hello? Ah, okay, there I am. Okay, so that was a quick one. So we have just even more time to do
yes,
a Q&A.
I prefer to answer some questions.
So when you talk about a platform, what is a platform for you? So what does it exactly mean? Is it, for example, just a cloud-based platform, or can it be done on-premise, for example?
It's basically a cloud-based platform that we operate and we run by our own. But we also provide individual software solutions based on the same architecture, based on the same components. So if you need a specific application that should run in your own data center, we can also provide this software very easily and quickly.
Okay. So before I talked a lot about consulting and what the role of consulting in this world is. What is the role of consulting in your company?
Well, I think the role of consulting is that usually we go to our customers most of the time together with our partner who provides hardware, and we first have to figure out what is the problem of our customer. Okay. And if we figured out the problem, we can decide, okay, how can we help you? And that is basically the part. You always need the hardware part and you need the software part. And so because we've got such a good network, we're able to provide both of it.
But isn't that really then a standard problem? So if you plug the hardware into that, is it something? Isn't that every time totally unique? The machine's unique, everything unique. How can you plug standard hardware to the machines?
Well, the hardware that we use is equipped with different interfaces. For example, serial communication or digital input-output. Yeah. Of course, there might be some implementation effort necessary to really connect to the device and to get a wide range of information, for example. But easy applications, for example, to just get notified if the power falls off, if the machine falls down, can very easily be integrated. And then that's also only a first scenario. So most of our customers have the need to get, for example, an email or push message if there's something wrong. And that can be realized very fast. And once they've implemented the first solution, it's very easily to widen the solution, for example, with respect or in the context of predictive maintenance and stuff like that. So we can build up on this, and we can first start with a very small and specific solution.
Okay, one final question. Can you give us one concrete case?
Yes, for example, we are monitoring wastewater treatment systems. And we do not only get all the information from the wastewater treatment system every day to log all information and to see, for example, if some parts of the system need to be replaced. We also directly get messages if there's something wrong, if the system falls down and stuff like that.
Okay, I think that was my question for now. That were my questions for now. If you have any question, I think you are here.
Yes, I'm here, of course.
Okay, thank you very much.
Thank you.
So, please, I think it's because afterwards we have a session also for question and answers. So I think you can sit here directly, and the next one will come. Please welcome on stage Oden Technologies.
Hello, hi. My name is Willem Sundblad, and I'm the founder and CEO of Odin Technologies. And we create smart factories. So it's a hardware and software solution that connects to industrial machinery, quality assurance equipment, or to sensors that we add to production lines. We take the machine and production performance data, send it in real time over a machine-to-machine network to our cloud-based analytics platform, where we visualize process flows and problems. So run rates, rejection rates, machine downtime causes, frequencies, lead times. So the manufacturers can understand where the current problems are and then use alerts to make the insights actionable. So either based on flow targets and metrics that we track, or based on events that happen, like machine downtime or reoccurring downtime. We also use machine learning to predict machine downtime and quality rejections. So we look for patterns in the data that leads to the machine breaking, or patterns that lead to rejections, and we then can send warnings about that. And so we are going live with our first customer, which is 3 factories, 3 cable manufacturing plants in the US at the end of April. So we're in the final bits of development now.
Thanks. Also a quick one.
Yeah.
Cool. So I start directly with my questions. You talked about machine learning.
Yes.
And I had the talk before, and obviously I need to talk about that then. What does machine learning really mean for you? Do you program all that by own? Do you use standard APIs, for example? Do you use standard libraries, programming libraries for that? Or how does it work in your case when you want to get the most out of the data?
Yes. So our lead architect and head developer used to be head of data analytics and database engineering for Magnetic, a data analytics company in New York. So he and I are actually working on our own models, but we are also testing with a machine learning platform as a service company in order to see which service provides the best, most accurate predictions. Mm-hmm. And the best solution is the one we'll actually implement with our customers.
And what does consulting mean for your company?
Well, we had a chat about this a couple of days ago, and really what we're trying to do is enable our platform for the customers to be their own consultants. So there's definitely a hands-on element in our own implementations where we teach them how to use it, and we're in constant contact with them to make sure that they're using it in the right way, seeing the value. Mm-hmm. But we want this platform to enable themselves to do their own analytics and sort of change the behavior in manufacturing of right now. Operators and production managers are taking decisions based on experience. We want them to start taking decisions based on analytics and insights instead.
Mm-hmm. And can you describe us your hardware or the hardware that you use to generate the data? How does it look like?
Well, it's a cased-in printed circuit board essentially, and it has
a what?
A PCB, a circuit board.
Okay.
That can connect to industrial machinery. So it's a little bit like a translator and a transmitter. So it translates from machine protocol the data into our Unison format and then sends it over GPRS. So each device has a little nano SIM on it.
That's it. Thank you very much.
Thank you.
So let's welcome the next one on stage. It's OptoForce. Stage is yours.
Thank you. Thank you very much. My name is Ákos, and I'm representing the company OptoForce. I'm the CEO, but I'm not one of the founders. And I'm super happy to be with this company because we are doing some super awesome things. And I'm going to start with telling you why it is important, and only afterwards I'm going to start telling you what we are actually doing. So if you look at the big picture, I mean, like really, really big picture, what has been happening in human history over time was that we went from spending 100% of our time gathering food and then like doing everything else that we could fit in like this tiny piece of time afterwards. But because we humans are lazy, we wanted to spend more time with families, with having chats, with spending time with our loved ones, and like, you know what. So we wanted to find new ways of doing things and inventing tools. And so we started with hammers, we started with all kinds of tools, first for the hand. So you wanted to increase first like how you can produce more things. Afterwards, we went on using other things like animals to do stuff for ourselves. And then, yeah, okay. Oh, thanks. Super. So then we started using machines, and now we are in the phase of using more and more elaborate machines that are doing more, so we are using more and more data analysis that the guys are doing. What we are doing is we are working with sensors, force sensors particularly, because this is something that has been missing from industry so far. So force sensors has been crazy expensive, costing over 6,000 euros a piece so far, which has limited their use. We have not been able to assemble things with robots so far because it was that expensive. Now we are bringing that cost down to under 10 euros in 5 years. So that's what we are doing right now, and we have our first clients already.
Okay, so as all of you have 2 minutes, we have to cut, but we have the question and answers, and as I'm kind, you can explain again what you are now exactly doing.
Thank you very much. Sorry. So we invented a new way of doing measurement of forces and torques in 3 axes. So it's a sensor. It's not an application. It's not a cloud computing thing, whatever. It is actually hardware, real hardware. And what it enables us to do is to do more automation with it. We have a light-based principle, so instead of using delicate materials as before, we are using a very sturdy construction based on light. So we separated the sensing element for the deforming element. I don't want to go much into details, but you can always check it in our booth. But that's actually what we are doing. So we can actually sense which way you are pushing the element from and how hard. And with that, we can measure vibrations of the machine, analyze them. We can lead robots, guide them to the right place. We can make the robots feel if they lift up a glass, if they push 2 things together, if they can feel if it clicks or if it doesn't click, if it's sliding out of their hands or if it doesn't.
Okay, so you plug a hardware to the robot, or
yes,
okay.
Yeah, we are building the hardware, yeah.
Okay, so and then the data directly flows into the system, which is responsible for moving, for example, of the.
Yeah, that's the job of the guys here. So they are using sensors like ours, for example. What we are focusing on is making these sensors smarter so that they can have more valid data.
Okay, and how does a cooperation then work like? So what is the experience in the past? So who is using that then really?
Right.
Oh.
Most of the time it's used in robotics, industrial robotics. If you want to have a very even surface, you need force feedback so that the robot actually knows how much force it is exerting on the part. Or if you want to assemble 2 parts, the robot actually needs to feel. That's the most.
Okay, so currently about robotics.
Currently robotics and increasingly more and more other industrial automation uses.
Okay, super. Thank you very much.
No, thank you.
So now, welcome on stage, PTX technical expertise.
Yes.
Thanks.
Hello. Thank you very much. Good morning, everybody. My name is Ferdinand Wiegelmann from PTX. We developed a system, 3D laser-based system, which is called 4D MMS, and 4D stands for 2D vision plus depth information plus time. This system is able to enable machines, vehicles, and robots, especially transport robots, to see and to recognize. You can use this system, for example, in the field of activity in machinery automation, for example. Now you have arms which move from A to B with our system, they are much more flexible. They can pick nearly everything they can see. And even if the part is totally different, it is able to see and to pick it. This is one example in the area of industry automation. Let's go to the field of automotive. In this area, we implement 4 sensors in the front of the car, in the back, and at the sides. And these sensors are able to create a 360-degree sphere, an image, and it is much more advanced than everything we have up to now in the sense of radar solution, ultrasound, or camera-based systems. For our system is also able to work if it's very foggy, if you have dust, if it's dark, if it's rainy, or you have snow, whatever it is. So, and we have a range of up to 50 meters now, and we work on 200 meters. In addition to this solution, we have a motion predictor. It means the car is moving and somebody, pedestrian, a child, whoever, is coming into the street, and we calculate a motion predictor. It's a combination of direction and speed, and we are able to use a brake to make this action, it's called collision avoidance, 5 seconds earlier.
Super, thank you very much.
That's not all.
Yeah, that's of course not all, but all of you have 2 minutes, so
Fine.
Thank you very much. First. So when you talk about a system, what does it really mean, a system, when you talk about a system, your system?
It's a 3D laser. It's a diffused, it means not focused laser. And what else do you have to understand? It works with infrared. It sends infrared beams. And we use 120 hertz. It means 100 beams per second. So it's really very, very high performing.
Okay, and what does your company doing about using the data then afterwards? So when you, for example, gave us the car example, what is your task then?
This could be a new business for us. So we don't do it. This is part of the customers.
Okay, currently it's totally out of your scope.
Yeah.
Okay. Anything else that you want to say?
For example, it's also a possibility in the sense of a new and more flexible man-machine interaction. For example, if you work together with robots, now very often robots are in hands, they are in a cage. With our solution, robots can see and you can cooperate, you know. Even very often you have companies over here, they offer tactile solutions, tactile sensors, but tactile means they push you and perhaps the push is too hard and you are dead at the end of the day. And let me say one more sentence. If you are able to enable machines to see and to recognize, you can do the same with blind and for blind people to help them to see and to recognize. We have developed a system and the information about barriers and so on. It's again collision avoidance. It's transferred via acoustical signals behind the ears. Now I finish with the promotion tour.
Okay, thanks. So I think now we have time to discuss a bit, all of us. And I find it very interesting that we see synergies, and of course we should have, because all of the whole hall here is about Internet of Things and also Industry 4.0, and that's the topic of today. But for example, how do you think can you help him?
Well, I mean, we could potentially be that cloud provider that takes the data and actually makes sense of it and visualizes it and turns it into action in some way. Right now, we're only focused on industrial machinery, but the technology is the same anyways.
Okay. I really would like to have an open discussion, so not Q&A again. So please feel free. If you have anything to ask one of the others, then please feel free doing that. So now you have 3 seconds to think about that.
All right, so let me just jump in. So I actually totally agree with him. So like, but the way I see this is that like we two together, we are building sensors who actually complement each other. So like they are seeing, we are feeling. We both, like you can't work without any of them actually. So like if you only have our sensors, the robot could like push it too much. But if they don't have ours, then like it would drop things. So and then these guys, they can bring these together and actually put a smart algorithm on it so that the system can actually do something with the data. I mean, data itself is useless, right? So it's like we need each other basically.
Yeah,
Right.
it could enlarge business models.
Could the PTX technology potentially be used to detect quality problems in manufacturing at an early stage? Let's say if the tooling starts to wear down a little bit and you see marks on your product that detects that this will break quite soon, could that be a potential use case? Because if so, it's very interesting.
For being very honest, up to now we have technical prototype. We still have to work half a year to finish the product for machinery automation. But we got some strong partners who are willing to cooperate.
Okay, one other thing what I found interesting, that your business and yours, it's very similar. What do you think do you make different?
Well, I think we don't focus as much as on data analytics and stuff like that. So we address the need of our customers to really, in the first stage, just to monitor the applications. And I don't know if you, for example, provide application stack based on mobile applications, stuff like that.
Well, we go directly to sort of niche targets within manufacturing in order to really ensure that the application delivers value and that the algorithms are actually fitting to their manufacturing processes. So right now it's only cable manufacturing in order to, like you talked about before, figure out what metrics they really need to track and make decisions. And then we're going to market one vertical at a time. So I don't think it's similar services, but not direct competitors.
Right.
Different strategies.
But we are, for example, more focusing on environmental solution and systems that are running somewhere out on the field and not as much in the factory. So I think it's also a difference.
Right.
Yeah.
By the way, where are you based? Where are you based?
We are from Dortmund, Germany.
Okay.
Yeah.
You?
We are in the neighborhood.
Ah, okay.
Ansbeck. Yeah.
You?
We are from Hungary, Budapest. Yeah.
We're London-based, but a little bit spread out. We have a software team in the US, hardware team in London and Eastern Europe, but the company is a UK company.
Okay. Yeah, I think if you have anything else to discuss, I'm not the biggest fan of Q&A because you are here now. And if you have anything that you want to discuss, then please feel free.
Well, it's actually quite interesting. I have just realized that we two might have something in common. It's funny because we are right next door to each other, like our booths.
Yeah.
But some of our clients are actually using the data that we provide to do vibration analysis, so that and based on that you can actually predict if a turning machine will go wrong over time, if the bearings are wearing out.
Yeah, that's very interesting.
Yeah.
That's very interesting. We'll definitely talk more about that.
Yeah, exactly.
I mean, right now we've sort of just developed the MVP that takes the data from the machines. But we're constantly looking at new developments and what else we can bring to the manufacturers that they themselves don't even know. And sort of image-based recognition to detect problems and vibrations and also sound, because there can be specific sounds that you can detect that a machine might break or that there's a problem with it somehow. That's all those extra things that's really interesting that we can come up with that they don't even know they might need. Right.
Generally speaking of the big pictures, I think it's a very interesting time right now because we have more and more better and better software to analyze this data. I think what I have seen so far from the other side is that it's quite hard to pick the right thing to analyze, to pick the right inputs. So there are thousands of sensors that you can use in a factory, but not necessarily all of them are useful for the client, right?
Yeah.
So,
for
example, how do you select which one is the one that you need for?
Well, so I mean, we're collecting everything that's available from the production line. But we actually spent a week with them last month to go through what are the actual metrics that, that drives the problems. What are the metrics that you need to see to make better decisions? So out of the 40, 50 different metrics that we're collecting, we're actually only visualizing 3 or 4 at the start, so they can understand how those correlate, and they can sort of click in a few more. But the rest of the data is sort of hidden as background data that they can go back and analyze. If there's been a problem, they can then see what was being made, what compound was being used, etc. But you're right, that goes back to sort of the consulting part of it. So in the beginning, you need to understand what actually creates value, and then only analyze and sort of make decisions based on that.
And here, all of you, we can see what you are doing, but do you, for example, have a use case also here, so that after the talk, people come
yes,
to you
of
and
course.
see?
Yeah. Sure.
Okay.
We've got a connected wind turbine, and you can see the live data, for example, on our dashboard, so you can directly see what's going on, how much wind is coming, and how much energy is produced. And we also have a connected coffee maker. So if you would like to have a coffee, just come over and you can get a coffee by using, for example, our iPhone app. And it demonstrates that you can connect different devices and different machines with just our single platform.
That sounds cool.
We have a big screen, and when people approach to our booth, the guests will be seen a little bit as it would be in a car, you know, you would see also pedestrians and so on when the people are in front of the car, but on the other hand, the screen in the car wouldn't be like that, just a small one.
Yeah.
Okay.
You guys have a great demo. People are always playing with your robotic fingers.
Actually, that's one of the reasons why we brought them here, because it's like very nicely showing what can be done mostly in the future. I mean, right now these robot hands are only used for research studies at various universities to grab things, but one of the producers of this, actually also Shadow Robot, a UK-based company from London. Their idea is that they want in the factories they want to have dexterous fingers so that they can actually substitute human workers. I mean, like it's not such nice to say, but I mean that's the reality. So that they can build hands or manipulators that can put things together in a nicer way. So that's like coming up in 10 years.
So do you think that the manual assembly line will be exchanged for robots that can...
Probably, very likely. Yeah.
Okay. Time is over. It was really inspiring. Thank you very much.
Thank you.